is that one? When you mix two compounds, what do you form physically?
A mixture.
Then compounds are mixed in which way? They are mixed chemically, isn't it? Yes? Yes? Then a compound, an element, is a pure substance that cannot be split into any other simple. Any other what? Yes?
To a simple substance.
Very good. Yesterday we looked at some elements there. There were how many?
20.
20. The first one we looked at is
Hydrogen.
hydrogen. The second one?
Helium.
Helium. Now that is one person talking. Ruth, helium. From helium, Ruth?
Lithium.
Lithium. Mutumba. Huh? Rebecca. The next one?
Beryllium.
Beryllium. Beryllium. The next one?
Boron.
Boron. Next?
Carbon.
Carbon.
Now we can't wait for Karamoja to develop. For us, we'll continue. The next one?
Nitrogen.
Nitrogen.
Nitrogen. The next one?
Oxygen.
Oxygen. Next one?
Fluorine.
Fluorine, yes.
Neon.
Neon. These are the first 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 7, 8, 9, 10. Those are the first 10. The other ones?
Sodium.
Sodium. Na.
Magnesium.
Magnesium. What was the symbol? M what?
Mg.
G.
Aluminium.
Al.
Silicon.
Silicon. Si.
Phosphorus.
Phosphorus, which was P.
Sulfur.
Sulfur.
Chlorine.
Chlorine, Cl.
Argon.
Argon.
Yeah.
Yes.
Argon.
Potassium.
Potassium, K. And
Calcium.
calcium. Those are our 20 elements we looked at. Now, in these elements, we saw that some names don't vary with some symbols don't vary. These are symbols, isn't it? Symbols.
Yes.
Some symbols don't vary with the name it is given. An example, sodium. This is sodium. Sodium. The name is supposed to be SO, maybe, but was given Na. What was the reason?
It was from a Latin name.
Latin name. What is that Latin name? What is the Latin? Natrium. It seems people are very attentive now. Rebecca, where are you? Are you in class? Yes? Rebecca? Rebecca? Somebody tell Rebecca to wake up. She should still stop sleeping. Rebecca, are you in class? So somebody was talking of looking at ways of forming these compounds. That was somebody's question yesterday. So I don't want to leave you when you don't know how to write a few of them, because in our discussions we stopped at this type of elements here. So we can look at a few of them and try to see how to form them. But before, there's like a simple table I've projected. Is it viewable? Is it viewable? Can you see something on the screen? On the camera here? IV cam.
Just a little.
Yeah,
Yes, a little. It's not clear.
it's
Yeah.
clear for me.
It's clear for you. So someone who's
Now
not
it's
seeing,
clear.
it is clear there.
Yeah.
So this is what you call what?
No.
How do you read this word?
Eh?
The word is Euclid. How do you read that word?
Valence.
Valence.
Manisha.
Not Valesa or not Valesa. The word is
Valence.
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 It's called valence. Valence 1. Okay. Then we have what?
Yeah.
2.
Let's
Then we have
Valence too.
valence 3.
3.
Okay. Now, I'm giving you a few minutes. If you can get that copy of that work of 1 and 2, I'm going to tell you the reason as to why I told you to copy. I've given you some of you. Draw that simple table like that, and then try to copy those things there. Valence 1, valence 2, and you put in all these elements 1, 2, 3, 4, 5. Then these ones, there are many as that. Okay. We have about 2 minutes to copy this work. You put for me this is plus, everywhere plus, 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 plus. You see this plus? I'm going to tell you what they mean. Then this other one's plus 2, plus 2, plus 2 also. Just like somebody requested to form some few compounds. So we are going to use that whatever to form some few. We shall be back after 2 minutes. Try to copy. Finished?
Cannot.
A. You are
No,
still copy.
teacher.
Okay.
Yes.
Copy.
Teacher, balance 3 is not C.
Shall we even copy valence 3?
Said copy that table. Teacher.
Now I got a final copy here on the other side of the screen. Do you see it? Yes?
Yes.
No.
Okay. Now this one is more clearer than the other one. So allow me or permit me withdraw this and we look at this. Is this one clear?
No.
Okay, there's a mistake here. This one is, thank you for the concern. Some concerned citizens saw that there was a mistake here. Okay, thank you for being observant. Now, if you can see this clearly, you can use maybe what, a screenshot?
Yeah, it's not clear.
Not this one, not the camera. Go to the other page of the notes. You are not seeing the whatever there.
I'm seeing it well now.
This one is clear, isn't it?
Yeah.
This one. So see this one clearly. I'm going to put it on as part of the work there. So you take note of that. Now we have seen how many words there? How many new words have you seen?
One.
New
One.
words. How many? Which one is that?
Balance.
Valence. Which other thing have you seen that is new?
Aluminium ion.
Aluminium ions. So the word is iron, but the word aluminium you saw yesterday, isn't it?
Yeah. Yeah.
Which other one?
Lead iron.
Lead iron, but we saw lead. Lead is one of the whatever's there, isn't it?
Yes.
For now, it is new because yesterday we saw copper, we saw lead is the one that wasn't there. Zinc is also here. Iron. Now, lithium, potassium. What about ammonia? Somebody saw it? Ammonia. The first one there in valence one. You saw it? No good.
No.
So it was not part of the what? So now here we are looking at this. We have seen this one, the cat ions.
Cat iron.
Ions. So that was just a minor mistake, but the name, the whatever continues. So the name is called cations. They are called positive ions. Positive ions. Two, we look at these ones, the negative ions. Negative ions, we have radicals. So there is another word we go. Radicals.
Radical.
Then we have radicals. If you look at valence one, there is what we call hydroxide, nitrate, nitrite, hydrogen carbonate, iodide, hydrogen sulfide, hydrogen sulfate, chloride, bromide. This one. This one, the name is called okay. Those are parts of those things there. Now, there is this, and then we have these two anions. Cations we have seen they are positively charged, isn't it? Huh?
Yes.
These are positively charged.
Charge.
Now, anions are negatively what? Negatively charged. Now, what is a charge? A charge is what we call the ion. This one can be a charged particle. So the ion is a charged what? Particle. So in chemistry, for whatever to react, it must be charged. So a charged particle, it can either be a positive or what? Negative. That is all.
Negative.
So positive is indicated by plus, and then the negative is indicated by
Minus.
negative. So the positively charged ions are called cations. Then negatively charged ions are called they are called what?
Iron.
Okay. If you know you have noise on the ground, we advise you to always mute your microphone. Okay. So those are two. Now, if you want to write this word, there is this word called valency. Valence in simple terms is the combining what? Power of an element. Okay?
Yes.
So the word valency in simple terms is called the combining power of an element. We have looked at this. We have looked at this. All these have a combining power of what? 1, isn't it? That's why they call them, they fall under valence what? 1. Is it clear?
Yes.
All these, the ones we look at it in this table, look at them on this table: magnesium, calcium, copper, lead, iron, and zinc. All these, their combining power is 2. We are going to look at how these things combine to give us a compound. Okay? Valence is 3. We have only 2: iron and aluminium. Now, iron occurs as there are 2. There is iron 2, then there is iron 3.
3.
So if the question defines iron 3, then you must use valence what? 3.
3.
If they just put iron or they put iron 2, you know that valence of iron is what? 2. Because originally iron occurs iron 2. Okay? But also iron 3 is there. So if the question comes and says copper 2, iron 3, you must write the valence of iron as 3, because it is the combining power of an element. If it is not there, you are writing a wrong compound. Okay?
Yes.
So now, when you are forming a compound, the positive ones always combine with negative ones under normal circumstances. Positive ions combine with negative what? Ions. But there is a stage also where positive ones can combine with positive ones, and they will give us what we call an alloy. You have heard of that word?
Yeah.
Yes.
But under normal circumstances, positive ions attract always negative what?
Iron.
Ions. That's how you form this. Okay? So we are left with only one word. So if you are writing this, which ion is this? How do you read this ion? The one I've highlighted here.
Ammonia.
No, the second one.
Silver.
This is silver. Silver. So silver, the symbol is Ag. And if you're writing the ion, you put it as 1. Instead of 1, since it is only 1, we indicate it with the plus. That's the way, instead of writing 1 plus or plus 1, all these mean the same thing. So instead of putting this is a waste of time. Just put plus. Okay?
Yes.
Good. If you are writing magnesium ion, you say magnesium, then the charge is what? 2. That's why it has 2 plus. The 2 appears there. You can't eliminate it. It must be there. Okay? It is always written at the top if it is the ion. On the top. There. So if something is written Ag plus, you know that substance has which valency?
Valence.
Valence 1, isn't it?
1.
Yeah, yeah. So if something has 2 plus, that thing has valence what? 2.
2.
If it is 3 plus, that is it is?
Valence 3.
Okay. So that is what you form there. So you look at these things critically. These ones, I'm giving you time to study them because we are going to use them. I see 80 minutes left for the first session to go off. Then the second session will be serious work now. Okay? Now, there are these elements that cannot occur alone. They cannot, if you say hydroxide, it can't be alone. They are always 2 or more elements combined together. Okay? Someone is shouting. Okay. That is okay. There are always these elements that are always 2 or 3 or 4 elements combined together. Now, if you have those elements 2, 3, 4 combined together, and in this state they cannot stand alone, then those elements qualify to be called radicals. Is it clear? So
Yes.
a radical in simple term is an element that contains 2 or more, is a substance, not an element, is a substance that contains 2 or more elements combined together but cannot stand alone. The two or more elements give us one general name, but for them, they cannot stand what? Alone. So here, so if a substance like this one, let's take an example, a sulfate. This is the way you write a sulfate. This is a sulfate. Sulfate. It is SO4. Then it has valence 2 negative. It is here. These ones, you have to know them. They were like that. They were discovered long time ago. There's no way you are going to make your own sulfate. Okay?
Hey.
So this is the way you write a sulfate. Now, if they remove this and replace it maybe by hydrogen, now hydrogen is going to replace one of these 2. And then what will remain is one of them will remain. So it becomes SO4. The whole of this is -1. What is the name of this? Yes, I've removed the 2. This 2 by replacing one of it by hydrogen. What does the name become? Somebody to try. If the name of the radical here is a sulfate, I replace this by hydrogen. What does the name become?
Hydrosulfur.
It is not hydro, but a hydrogen. Hydrogen what? Sulfate.
Sulfate.
Good. That is good. Now, if another element is like this, CO3, it has 2 minus. The name is a carbonate. A carbonate. If I replace these 2 by one of the hydrogen, CO3, and I become -1, what does the name become?
Hydrogen carbonate.
Hydrogen carbonate.
Hydrogen.
Thank you very much. So the name becomes hydrogen carbonate.
Carbonate.
Very good. Now, if I get S alone and it has 2 minus, the name is called sulfide. Sulfide. Okay? If I put, this is a sulfide, isn't it? Now, take note of this.
Yeah.
Yes. Now, at this stage, this is the iron. It is not sulfur, it is sulfide. It is the iron. Okay? Now, here, if it is SO, now this one was 4. Take note of this. And now this one becomes a 3. The name changes from A to sulfur. How do you read the name? How do you read this name?
Sulfite.
Sulfite. So if I replace this hydrogen here, I put here HO3 and it becomes like that. What does the name become?
Hydrogen sulfide.
Hydrogen sulfide. Okay? Hydrogen sulfide. Thank you very much. And many others. Now here I have the most common one, which is NO3. NO3, it has a valence 1, always. It is a negative radical. These are examples of radicals. A substance that has more than 2 elements combined together, 2 or more elements combined together, but cannot stand alone. If you write a sulfate, or a carbonate like this, you will never find one letter representing a carbonate. It is always CO3 and it has a valence of 2 minus. Okay? So here, if this is like this, the name is called a nitrate. Okay, now if you are not talking or if you are not doing anything, you mute your microphone because there is some noise on the ground. Allow others to listen also like the way you want. Okay, now this is what we have. A nitrate ion is written as this. I am going to tell you why this is very important in our second session. We are just learning how to write them. But after this, you are going to get this paper on the platform immediately, this paper here. So make sure you get used to these words. Make sure you get used to. So here we have those ones of valence 1. Hydroxide. Hydroxide is as written as this, hydroxide, which is OH, -1. The whole of it. So if they find the writing hydroxide as OH and then O is different from H, that's the wrong sign. All of it is power -1. That's hydroxide. So a nitrite is written as this. It is different from a nitrate. A nitrate is this, a nitrite is like this. A nitrite is NO2 and then -1. That's the power of a nitrite. They all have -1. They have valence 1. We have less than a minute. You can use the other minute. Maybe we shall come back after 1 minute and we continue. You first rest for 1 minute. Then we have a chloride. A chloride Cl, -bar. That's what we call a chloride. Then a bromide, then a chlorate. So a chlorate, a bromide is written as this, Br, -D. This is a bromide. For these ones, shall not look at them as much as that, but the most important one is a chlorate, which is C3 negative. The whole of it is a chlorate.